Hi friends, today we see airport design. In previous lecture we see airport planning. Now we see airport design. According to the International Civil Aviation Organization, that is ICAO, a runway is defined rectangular area on a land aerodrome prepared for the landing and takeoff of aircraft, that is runway. The orientation of the runway is an important consideration in airport planning and design. The correct runway orientation maximizes the possible use of the runway throughout the year, accounting for a wide variety of wind conditions. Federation Aviation Administration and ICAO regulation establish rules about runway orientation and their expected coverage. Runway location consideration. Federal Aviation Administration mandate identification standards for airport layout that is meant to assist pilot in easily recognize runways. Runway is usually oriented in the direction of prevailing winds. The head wind, that is the wind direction of wind opposite to the direction of landing and taking off, provides greater lift on the wings of the aircraft when it is taking off. As such, the aircraft rises above the ground much earlier and in a shorter length of runway. During landing, the headwind provides a braking effect and the aircraft come to a stop in a smaller length of a runway. Landing and takeoff operations, if done along the wind direction, would require longer runway. The challenge for the designer is to accommodate all the aircraft using the facility in a reliable and reasonable manners. In figure, in navigation, all measurement of direction is performed by using the number of compass. In figure, we see one type of compass which consists of the angle from 0 degree to 360 degree in a circle. Next is objective of design. Design and plan airport layout design facility required for runway, taxiway and impart knowledge about visual aids to the pilot. Next point is wind rose diagram. Runway orientation using wind rose. The wind data, that is direction, duration and intensity, are graphically represented by a diagram called as wind rose diagram. The plotting of the wind rose diagram can be done in the two ways. First type is showing direction and duration of wind, and second type is showing direction, duration and intensity of wind also. Then crosswind component of wind diagram. It is not possible to get the direction of opposite wind parallel to the center line of the runway length every day or throughout the year. If the direction of wind is at an angle to the runway center line, is its component along the direction of runway will be v cos theta, and that normal to the runway center line will be v sin theta. where v is the wind velocity. The normal component of the wind is called crosswind component. Crosswind component should be not exceed 25 km per hour for mixed traffic. Next point is wind coverage. The percentage of time in a year during which the crosswind component remains within the limit of 25 km per hour is called as wind coverage of the runway. According to Federal Aviation Administration, that is FAA, the runway handling mixed air traffic should be so planned that for 95% of time in a year for busy airports the wind coverage may be increased to 98 to 100%. Type 1 windows diagram, in which the radial lines indicate the wind direction and each circle represent the duration of wind to a certain scale. The total percentage of wind blowing in each direction are plotted and then joined by straight lines. The best direction of runway is indicated along the direction of longest line on the windrows diagram. Second type of windrows diagram, in which it is observed that the percentage of time during which the wind velocity is less than 6 km per hour works out to be 100 to 88, that is equal to 100 minus 88, that is 12. This period is called the calm period and does not influence the operation of landing and takeoff because of low wind velocity. The wind velocities below 6 km per hour have no effect on the fixing of orientation of a runway. Wind velocity below 6, the concentric circles with radius corresponding to 6, 25, 50 and 80 km per hour to subscale are drawn. Thus, each circle represents the wind velocity sum scale. Next point is runway length. It is the length of runway under the following assumed condition. First condition is airport altitude is at sea level. Second is temperature at the airport is standard, that is 15 degrees Celsius. Runway is leveled in the longitudinal direction. No wind is blowing on runway. Aircraft is loaded to its full loading carrying capacity. And last condition is en route temperature is standard. Next point is corrections for elevation, temperature and gradient. The basic runway length as discussed is for mean sea level elevation having standard atmospheric conditions. Necessary corrections are therefore applied for any change in elevation, temperature and gradient for the actual site construction. Next is correction for elevation. As the elevation increases, the air density reduces. This is in turn reduce the lift on the wings of the aircraft, and the aircraft require greater ground speed before it can rise into the air. To achieve greater speed, longer length of runway is required. And last is ICAO recommends that the basic runway length should be increased at the rate of 7% per 300 meter rise in elevation above the mean sea level. Next is correction for temperature. The rise in airport reference temperature has the same effect as that of the increase in elevation. Airport reference temperature is defined as the monthly mean of average daily temperature, that is TA, for the hottest month of the year plus one third the difference of this temperature and the monthly mean of the maximum daily temperature, that is TM, for the same month of the year. ICAO recommends that the basic runway length after having been corrected for elevation should be further increased at the rate of 1% for every 1 degree Celsius rise of airport reference temperature above the standard atmospheric temperature at that elevation. Next is correction of gradient. Steeper gradient result in greater consumption of energy, and as such longer length of runway is required to attain the desired ground speed. ICAO does not recommend any specific correction for the gradient. FAA recommends that the runway length after having corrected for elevation and temperature should be further increased at the rate of 20% for every 1% of effective gradient. Effective gradient is defined as the maximum difference in elevation between the highest and lowest point of runway divided by the total length of runway.